Hi, we are going to talk about Sphere, a simulation platform for a heterogeneous wireless system that emulates simultaneously the transmission of GPRS, Edge multi-slot, AS, DPA, and wireless LAN at the packet level, which allow conducting novel investigations on common radio resource management for beyond 3G system or on the optimization of resource management techniques. Well, the cellular environment entity is a system model storing the location of each base station and the interference relation among them. This information is needed to estimate the experienced interface levels. The cellular layout can be modified offline at any time to change the system configuration on the study. Currently, the Sphere platform considers a cell layout of 27 omnidirectional cells. In order to avoid border effects, a wrap-around technique has been applied. 3 sectorized cell sites have also been modeled. A basic scenario has been defined considering 2 concentric coverage cells. With increasing cell radius, the smaller one of 50 meters represents the coverage area of wireless LAN technology. The second coverage radius of 500 meters include HSDPA, Edge, and GPRS. Figure 1 shows the scenario modeled by the Sphere platform, which include the GPRS, Edge, HSDPA, and wireless LAN radio interface, as shown in Figure 1. The entity directly collects a specific RAD information.
I'll be talking about the radio link model. This module models the radio propagation condition between transmitter and receiver, and is a generic entity employed by any wireless link established. It characterizes the 3 radio propagation effects, namely path loss, shadowing, and fast fading. The path loss model provides an average measure of the signal attenuation over a given distance. For a cellular system, the path loss in dBs report it has been considered as this equation. This represents the loss in the first equation, where d is the distance and in kilometers between the base station transceiver and the mobile terminal. XOI is the carrier frequency in megahertz, and AHB is the base station antenna height, measured in meters from the average rooftop level in AHPD. Typical values for these parameters are AHB 15 meters and F 2000 megahertz, leading to L sub P in dBs, like this. This model is applicable to frequencies ranging from 1.5 GHz up to 2 GHz. As a result, a carrier frequency of 1.8 GHz have been assumed for GPRS and H. This change in the frequency pattern result in the following path loss equation. This one. Studies have demonstrated the importance of proper shading models to carry out investigation, RREM. In fact, the shadow effect results in additional signal attenuation due to the obstacles in the path between the transmitter and receiver. Measurement has shown that the loss of shade can be modeled as a random process with a normal distribution of mean ODBs and a standard deviation between 4 and 12 dBs depending on propagation environment. The platform Sphere considers an urban or suburban environment, and therefore a standard deviation equal to 6 shade has been established. The shadow is spatially correlated process. For WLAN, the path loss model has been implemented as follows. These 4 equations. Several studies have demonstrated the importance of proper shading models to carry out investigation. RRM this. In fact, the shadow effect results in additional signal attenuation due to the obstacles in the path between transmitter and receiver. Measurements have shown that the loss of shade height can be modeled as a random process with a normal distribution?
Well, now we're going to talk about radio result management. The EFRA has been simulated considering different multi-slot configurations. This value has been obtained by simulating the diverse range of the system independently and considering a lot of 15 users per cell in each simulation. In this simulation, wireless LAN users mobility is restricted to their system merits. Cells radius. As it can be observed from the figure 3, the performance per rad doesn't overpass their maximum theoretical values, which validates the current implementation of the STER platform. In fact, the performance is lower than the maximum theoretical values given the low cells radius. High transmitting power and high cell load used to conduct this simulation. These conditions increase the interference levels, which in turn increase the experiences blend, decrease the throughput performance and promote inadaptive radio interface shocks. As thus modeled in spheres, the user's transmission mode with higher protection and lower bitrate. And figure 3, throughput performance is improved when using R instead of CC. This improvement is due to the higher IR probability of successfully decoding retransmitting block, giving that it sends additional redundancy information. With each retransmission results clearly show that the sphere platform offers a considerably wide range of transmission capability, highlighting its survivability.
Edge multi-channel operation. The authors are working on a new arrangement for multi-channel operation design to effectively distribute scarce resources among users, according to the system status and user needs on the basis of certain words of QoS and services type requests. In particular, the authors of working on theory of bankruptcy and schemes based on the usefulness of a scenario of multiple services. The assessment technique includes discrete restriction, equality award, DCEA, the loss of discrete restriction equality, DCEL, the maximum utility and data evaluation scheme required. In DCEA, resources are first allocated to best user until all users get the satisfaction of the user themselves. In case the user satisfaction of equality cannot be achieved, priority users. DCEL follow a similar work except that user first obtain all necessary resources to ensure maximum of user satisfaction, and resources are reduced sequentially to try to ensure the end of the distribution channel. DCEL follows a similar work except that user first obtain all necessary resources to ensure maximum user satisfaction, and resources are reduced sequentially to try to ensure the end of distribution channel of the same level of satisfaction user. As for the DCEA, if the goal is not possible, real-time services are prioritized. In the scheme, max util channels are assigned to users who will see a major increase in user satisfaction if a channel is assigned to them. So now, in order to conclusion, Sphere is a radio simulation platform for a heterogeneous wireless system, who probably is going to be very useful to these next years. So now we are all set. Hopefully this presentation has been enjoyable for yourself.